Hi everyone, good morning. Can you see my screen everyone? Can you hear me everyone? Am I audible? Fine. So in the last session we discussed about SDLC, right? Software Development Lifecycle. So how developer develop the code, how the code will be, how the code will be moved to remote repository. From there, from remote repository, how the Jenkins will take the code, how the raw code will be converted to artifact, right? So how the code will be deployed onto respect to target servers. These are all we discussed, right? Yeah. On SDLC, anyone having any questions? In the last session, we discussed about SDLC, Software Development Lifecycle. So in SDLC, anyone having any questions? Anyone newly joined today? Can you share your WhatsApp number and email address in the chat so that we'll provide you all the previous recordings. My mobile number is 96422111711. So everyone can take down this number. This is my number, personal number. So trainers, they never share their personal numbers. Okay. From Harsha Trainings, we share our numbers. Fine. Yeah, you can take down this number. So if you have any more questions, if you want to discuss anything, you can reach out to me. Fine. Yeah, new guys, whoever joined today, you can take down my number. Fine. Yeah, let's get started. So today and tomorrow we are going to work on servers and networks. So before going to cloud, we need to understand this, right? So what is server? What is network? What is switch? What is router? What is load balancer? What is IP address? What is subnet mask? What is gateway? So these are all very, very important, right? So before moving to cloud, we need to understand this terminology. If you understand this, you can easily cope up in the cloud. Fine. Yeah. So what is So here agenda here is what is server, types of servers, server client model and best practices, server architecture, what is operating system, types of operating system, what is network, types of networks, what is IP address, subnet mask, gateway, router, firewall, failover, load balancer. So these are all very important. Okay. Yeah. So today we are going to work on servers. Okay. Yeah. Basically, what is server? What is server, anyone? What is server? Server is a server is a computer, right? Server is a computer. Server is having high computing power. So high memory, high CPU, high storage is available in the server, right? Yeah. So in real-time projects, always we connect the servers, right? So developers always they connect the servers. Testers always they connect the servers. DevOps leaders also always connect the servers. They store the data, they modify the data, they check on the, they work on the yeah backups and all, right? Yeah. So server is having high computing power, right? So see here, this is the definition. A server is a computer that serves information to other computers called clients. What is client? Client is a desktop or laptop, right? So server is a computer that serves information to other computers, laptops or desktops. For example, once you join the project, we'll get one laptop or a desktop, right? So we can use that laptop to connect our office network, right? And we can connect our servers also through network, right? Yeah. So server is a computer that serves information to other computers called clients. Can connect to a server through either local area network or wide area network, such as the internet, through LAN connectivity or WAN connectivity, local area network or wide area network, or through Wi-Fi we can connect our servers. Fine. So types of servers, what are the types available? Here we have three types of servers available. First one is the blade server. Blade server. What is blade server? So these are the modular servers. So inside of the container, we insert small servers, right? Which are, we can say, blade servers. So these servers are highly capable, right? So currently we are using in large data centers. This blade servers we are using in large enterprise level data centers like Google Data Center, Microsoft Data Center, UHG Data Center, Verizon Data Center. So major companies enterprise level, we are using blade servers currently, right? So second one is rack server. What is rack server, anyone? What is rack server? So this is the traditional server. This is the traditional server. So instead of the rack, we can insert servers and we can connect power, network, right? We can install operating system. We can use the servers, rack servers, right? So most of the server rooms, data centers, currently we are using rack servers, right? Next one is tower server. What is tower server? So which is bit older server, right? So it is a tower. Instead of a tower, only one server you can configure. Only single server you can configure. So inside of that, we can, yeah, so we can connect a CPU, we can connect a keyboard, mouse, monitor also here. It is a tower server. Fine. Yeah, these are the three types of servers. See here. So blade server is a modular server that allows multiple servers to be hosted in a smaller area like this. So these servers are physically thin and typically only have CPU, memory, and integrated network controllers. Right? CPU, memory, integrated network controllers. And sometimes storage drives inbuilt here. Sometimes storage drives inbuilt here. Right? So blade servers are often seen in large data centers, enterprise level data centers. We see this blade servers. Next one is rack server. What is rack server? A rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. Rack server. What is rack server? It is a, yeah. So modular server. We can say modular server. Okay. Next one is a tower server. What is tower server? So tower server is a computer that is built in upright cabinet that stands alone and that is designed to function as a server. This is the tower server. Okay. Next one is the client server model. What is client server model? So we can connect our servers through network. Either we can use desktop or laptop to connect our servers, right? Yeah. So when we send request to the server, we'll give a response, right? For example, hospitals, right? And also colleges, schools. We configure one server in server room. So, for example, in hospital, OP, and other counters, uh, medical hall, right? So they can connect server. They can pick the data from central, right? Either desktop or laptop we can use to connect our server. We can connect through either local network or Wi-Fi, right? So servers give response when we send the request here. Okay. Yeah. So this is another client server model. See here. Through internet we can connect our servers. Through, yeah, we can use the laptop or desktop or even we can use the tab mobile also to connect our servers through internet or Wi-Fi. Fine. So next one is server architecture. So what is server architecture? Server architecture is a foundation layout or model of a server based on which a server is created and are deployed. If defines how server is designed. Okay, let's try to understand server architecture here. Server architecture. Yeah. So this we can say first phase of implementation. So this we can say first phase of implementation. So we can say, yeah, initial phase of implementation or first phase of implementation. Okay. Yeah. In 1990s, in 1990s and early 2000. So when the project teams want to deploy four applications, for example. So here we have Java, Python, Ruby, right? And also we can say Tomcat. Okay. So these are the four applications are available. Four different applications, for example. Okay. Yeah. So project teams in 1990s and early 2000, when they want to deploy four applications, what they used to do, they used to take four different servers. They used to take four different servers. Okay, yeah. So here, project teams used to take four different servers for four different applications like this, right? Yeah. So by the time in 1990s and early 2000, highest capacity of the storage is 1 GB storage. 1 GB storage is the highest capacity. So these are all 1 GB storage servers. 1 GB is the highest capacity, right? So in this highest capacity servers, we can deploy the required applications, right? Yeah. So here, for example, in this server, Java deployed. So Java will occupy here, for example, 300 MB. For example, I'm saying, right? So by the time in 1990s and early 2000, for each application they used to take one server, right? So Java occupy 300 MB, for example. Here remaining space will be, so remaining space here, which is 700 MB, will be wasted, right? So 300 MB only occupied here. So next one, Python. We installed Python on this server. So Python occupied, for example, 350 MB. Remaining space 650 space will be wasted. 650 MB space will be wasted here. Okay. So next one is Ruby. So occupied 400 MB, for example. Remaining space will be wasted here. Right. So next one is a Tomcat. So Tomcat application occupied, so 500 MB or else 450 MB. Okay. So remaining space is wasted here. Remaining space is remaining 550 MB is wasted here. Okay. Yeah. So here 1990s and early 2000, project teams used to take servers for one application, one server. They used to configure, right? So here, by the time hardware costing, it was very higher in 1990s and early 2000. So by the time desktop costing also very higher, laptop costing also very higher, server costing too much cost. So by the time project teams used to spend more budget for the hardware, right? So here what happened here, so when we use this model, what will happen here, what happened, so here server utilization is less, server utilization is very less, but the costing is more, right? So that is why this is a failed concept. This concept, it was failed. This concept failed. So because hardware costing is too much costing, but utilization is very less. That is why this concept is failed. Okay. Slowly, slowly, in second phase of implementation, in second phase of implementation, so what happened here? So after 2000, yeah, project teams used to take one high capacity server, one high capacity server. In this server, they used to deploy all the applications, right? So here, Java, Python, Ruby, and also Tomcat. So project teams used to take high-end capacity server. They used to deploy all the packages, all the applications in the same server, right? So in this model, what happened here? So here, Java user may access Java application. So Python user may access Python application. Ruby user may access Ruby application, and Tomcat user may access Tomcat application, right? So respective engineers, they access their respective application, right? But here the problem is, so Java user may access Python application also. There may be chances to access, right? So Python user may access Ruby application also. There may be chances to access. So Ruby user may access Tomcat application also. There may be chances to access. You understand it right, everyone? So four users are connecting same server. There may be chances to access other application also. For example, four people are staying in one flat, 2 BHK flat. Two people are staying in one room, two people are staying in other room. The four people commonly access kitchen and dining room. The same way, here four people are connecting the server. They can access, they can, yeah, there may be chances to access other applications also, right? So, and also, moreover, in case this service crash, what will happen? In case the service crash, what will happen? So all the applications will be gone. That is why this is also failed concept. Okay, here also we have drawbacks. Okay, so first concept is failed, second concept, second model also failed. Okay, slowly, yeah. Next model, third phase of implementation. The third phase of implementation. What happened here? Virtual servers came into market. Virtual servers, virtualization. We can say virtualization. So what is virtualization? So here what we will do? We take one physical server, higher capacity server, physical server, right? So in virtual environment, what we will do? We can take one physical server. So this server we can say this is a base operating system, base OS. This server is a physical server. So on top of this, what we will do? We deploy software, which is we can say VMware or hypervisor or Citrix. VMware, hypervisor or Citrix. So this is the software. VMware software, hypervisor software. So Citrix also software. So this software we need to deploy on the server. So once you deploy, what will happen here? So this will allow you to create virtual servers. What is virtual server? Anyone? Anyone having idea? What is virtual server? Anyone? What is virtual server? Anyone having idea? What is virtual server? Virtual server. Virtual server is a cloud server. Yes, that is, yeah, that is correct. But what is virtual server? Virtual server is not physical server. Virtual server is not physical server. It is a imaginary server. Virtual meeting, virtualization, right? Virtual calls, right? What is that? Which is not physical. Which is not physical, right? Yeah. So we can say imaginary server, right? Yeah. Now, so we take one server. On top of that, we can install some software that will allow you to create virtual servers, right? So now on top of this, what we will do? We can create virtual servers. These are the virtual servers. 5 into 5, 25 servers. Okay. So here we can deploy different operating systems like Windows. Here we can deploy Windows 2016. Here we can deploy Ubuntu. Here we can deploy CentOS. Here we can deploy RHCL. Here we can deploy Windows 2022 like this. So whatever operating environments you want to deploy, can deploy this. So based on the physical server capacity, we can create the virtual servers here, right? So this base server is having high computing power, like RAM, RAM 48 GB, CPU, CPU 32 core, and storage 10 TB, like this. High capacity server. This is high capacity server. Yeah, so this virtual servers will take the resource from physical server. You understand that everyone? These virtual servers take the resource from physical server. So this physical server. So virtual server, physical server functionality is same, right? So currently we are using cloud servers, right? Cloud servers are not physical servers, right? We are connecting virtually. For example, if you go and check here in AWS, see here. So this is a Jenkins server. Jenkins server. So we are using this server. This is other batch server. Okay. So this server is not physical. This is virtual. But this server created in AWS data center. So backend there is a physical server. Backend there is a physical server in AWS data center. So on top of that we created the virtual server, which is a AWS server. Okay, you understand that concept here? Yeah. So these are the virtual servers. 5 into 5, 25 servers. Okay. So virtual servers, physical server functionality is same. Okay. Yeah. Fine. So here we can create different operating systems on the servers, right? So when you want to install Windows or any operating system, so here we required ISO image, ISO image. So when you want to install operating system OS, we require ISO image. What is ISO? So International Standardization Organization, ISO full form. So image, for example, in your laptop, so you want to install Windows, you want to install latest Windows. How can we install Windows on laptop? We require one image, right? We copy that image into pen drive, and pen drive we can configure as a bootable drive. We can connect our laptop, connect to the laptop, and we can install Windows. So if you go to hardware center, what they will do? They copy image into pen drive, they connect the pen drive, they install operating system, right? Yeah. So the same way in here in virtual server side also we use the ISO image, right? It is a full package of the image. By using that, we can create server, we can create operating systems, right? So this image size would be 6 GB to 18 GB. This image size would be 6 GB to 18 GB minimum. Okay. So if you take Windows, it would be 17 GB or 18 GB. If you take Ubuntu, so 6.5 GB like that, right? Yeah. So here we have 25 servers are there, right? So these are the 5 servers, 5 into 5, 25 servers are there, right? So here on an average, each server take 10 GB for example. So on an average, each server taking storage 10 GB, 10 into 25. So 250 GB we need to spend for only operating system. So on top of that, we need to install Java, Git, Maven, Jenkins, whatever plugins, patches. That will take more space. You understanding that, everyone? Yeah. So still currently we are using virtual servers. VMware servers are hypervisor servers. But here also some drawbacks are there. In third phase of implementation also we have drawbacks, right? Yeah. And also when you restart this server, when you restart or reboot both are same. Restart or reboot. When you restart the server, it takes 4 to 8 minutes. When you restart server, it takes 4 to 8 minutes. Normally, when you restart laptop, within few seconds it will be restarted. But server side, it takes 4 to 8 minutes. Why this much of time it will take? Because backend services will run, updates will run, processes will run, right? So it will stop all the services one by one and it will restart. That is why 4 to 8 minutes it will take, right? And also here Deployment time and downtime is very higher. Deployment time and downtime is high. What is deployment time? What is downtime, anyone? What is deployment time? When you want to deploy any applications, that will take more time. So what is downtime, anyone? What is downtime? Real time, guys. What is downtime? What is downtime, anyone? Downtime is a, it is a server downtime. It is fine. What is downtime? It is a maintenance time, server unavailability time, maintenance time. Okay. So normally in real-time projects, so when you want to perform any major activities, okay, so once we perform that, we restart the servers, we shut down the servers, right? So that is the maintenance time, we can say maintenance time. Okay. So here restart time 4 to 8 minutes. Okay. So client will not accept this much of time. For example, so we deployed in the server, in the server we deployed, or else in this server we deployed one package which is one application which is Flipkart. Flipkart application we deployed on this server. Okay. So if you restart or reboot server, it is taking 8 minutes every time. So when you restart server, it is taking 8 minutes, for example. So yeah, if the server Flipkart is down for 8 minutes, business will be impacted, right? So globally, people will connect to the Flipkart, right? If the server is down for 8 minutes, application will not be accessible, right? So we cannot access the Flipkart application. So that is why client will not allow you to down the servers. Okay. So here when we restart server, it takes 4 to 8 minutes, right? So deployment time and downtime is very higher here. So that is why. So here also we have some drawbacks are there. So storage utilization. So 6 GB to 18 GB utilized here. Storage. Storage costing is very higher here, right? So applications, patches, everything you need to install on this. It takes more space, right? So this is also, yeah, virtualization also, virtual environment also having some drawbacks here. In the third phase implementation, so in virtualization, virtual servers also, so virtual servers also we have drawbacks here. That is why, so in fourth phase of implementation, yeah, this is very important one, fourth phase of implementation. So here we are using Docker containers. So this concept is very advanced concept, Docker concepts. So currently most of the project teams, they are migrating applications to Docker, right? So basically what is Docker? Docker, right? So Docker, we can say here Docker architecture, right? So you can say here containers, Docker containers. Okay. So what is Docker? Docker is a container tool. Docker is a container tool. What is container? Container is a lightweight standalone executable program. So container, when we talk about container, it is just like a box. We can move anywhere, we can use anywhere. So containers, we can move anywhere, we can use anywhere. So these are the containers. Container is the advanced concept. So currently, most of the project teams are using Docker containers. Okay. So how the Docker architecture would be? Let's try to understand. For example, this is my Docker server. This we can say Docker server. So this we can say AWS server, AWS EC2. So EC2 is the server name. In AWS server, we can call it as EC2. EC2 instance. In AWS server, we can call it as EC2 instance. This terminology is very very important. Okay, yeah. In Azure, we'll call it as VM. In Google Cloud, we can call it as VM instance. The server, we can call it as. The terminology is very important. Okay, so this is the Docker server. We can take Docker server. On top of this server, we can deploy one package which is Docker image. Docker image. So once we deploy image here, so this will allow you to create the containers like this. So this will allow you to create the containers. Okay. So in this containers, we can deploy different operating environments. Okay. So this is the, yeah, this we can say Windows container, right? Windows 2019. So here we can say RHCL, Linux, Red Hat Enterprise Linux. So here we can say Ubuntu. So Linux flavor. Here we can say CentOS, Linux flavor, right? Yeah. So these are the Docker containers. These are the Docker containers. So when we run the container, so in Docker, only lib and bin files will be created here. Library binary files only created here. So when we run the container, inside of the container, only library binary files will be created. Okay. So here, when we create container, when we deploy operating system on a container, so it will take 200 MB of the size only. 200 MB operating system size. It takes 200 MB. So here 6 GB to 18 GB, but Docker side 200 MB. It is a very less size, right? Lightweight, right? Very lightweight. So and also here, yeah. So when we restart container, it takes 15 seconds only. 15 seconds. When we restart any container, it takes 15 seconds only, right? So very faster. Okay. And also here, deployment time and downtime is very less. Deployment time and downtime is less, okay, compared to virtual servers. Okay, yeah. So currently we are using Flipkart, Amazon shopping site, Myntra, Misho. These are all digital applications, right? So those applications deployed on Docker containers, right? So that is why when we book any product, so even groceries within 5-10 minutes also we are getting, right? So Blinkit, Jepto, Danjo, these are all groceries we can book in the website, that applications, right? So when we book any groceries, within 5 minutes or 10 minutes they are delivering. So how the request will be processed? Because backend there is a high capacity containers, backend Docker containers are available. So in 2020 lockdown time, so everyone use the online shopping only, right? So because Docker containers, backend we have Docker containers. Okay, yeah. So recently I booked one mobile. So I received the mobile within 4 hours. Recently, very recently, OnePlus latest mobile, I booked that mobile. So within 4 hours I got that mobile, right? So earlier, 4 years back, 3 years back, when we book mobile or anything, they used to take 1 week time, right? So yeah, when I book the mobile, within 4 hours they deliver, because backend we have Docker containers are there. So when we place the order, that will be processed within few seconds. Understanding, right, everyone? Yeah. Currently, every project team, they're using Docker containers. These are all advanced concepts. Okay. So instead of using virtual servers, currently we are using Docker containers. If you are good in Docker or Kubernetes, you can easily crack your entry. So learning Docker and Kubernetes is very interesting. These concepts are very interesting concepts. Very simple way we can learn this. Okay, but we need to spend time. We need to focus. We need to spend time so that we can easily learn. Okay, yeah. Now, so when we deploy any applications on Docker, so quickly that applications will be accessible, very faster. Okay, and also here Docker launched in 2013. Docker launched in 2013, right? Yeah. So immediately after 1 year, Kubernetes launched. Immediately after 1 year, Kubernetes launched. Yeah. So Kubernetes launched in 2014. So Docker developed by Docker Inc. Kubernetes developed by Google. Kubernetes is a Google product. So currently Docker, Kubernetes both are very core advanced tools, right? Yeah, if you learn these tools, you can easily crack your entry. Okay. So along with this, one cloud platform should be required and a Jenkins also required. Okay. Yeah. So and also here, moreover, so Docker licensing cost is very less. Docker licensing cost is very less compared to virtual servers. So client always look for the cost saving, right? Client always look for the cost saving. Cost should be saved, right? So licensing cost is very less here. Docker licensing cost is very less, and time saving, cost saving in the Docker. So that is why currently, so every project team they are migrating their applications to Docker containers. So while working on Docker, we'll go deep dive. So Docker nearly 8 sessions it will take, nearly. Okay, nearly 8 sessions it will take. So we'll go deep dive and in live. So how we perform the activities, same way we can perform in our classes. Okay, so in Docker container we deploy live applications. How can we deploy? How can we access? How can we work on those applications? We'll see that practically. Clear it, everyone? Any questions up to here, anyone? Up to here, any questions, anyone? Yeah. So here, before Docker also we used to use some containers. Before Docker also we used to use containers. Before Docker. So before Docker we used to use some containers which are like before Docker. What happened here? We used to use LXC, LXC container, and also Jones, and also LMCI-FI. So LXC is a, it is a Linux container. Jones is a Solaris container. Solaris container. LMCI-FI, it is a Google container, right? So LXC, Linux container, Solaris container, Google container. So these containers we can say, these containers we can say, these containers are failed. These containers are failed. So these containers we can say platform dependent containers. So these are all we can say platform dependent containers. What is platform dependent, anyone? What is platform dependent, anyone? Platform dependent. What is that? Right. So all in case, yeah, OS based works on, okay, respect to OS. Right. So platform dependent is nothing but so LXC will run on only Linux. Jones will run on only Solaris. LMCI-FI will run on only Google. Right. So that is why these containers are failed. These containers are failed because only the respective platforms it will run. Okay. Yeah. So why the Docker is very popular? Why Docker is popular? Why the Docker is very famous currently? Okay. So irrespective of operating system, we can run Docker containers on Linux, Windows, Solaris, even Mac OS also. Mac OS also. Okay. So on any platform we can run this Docker containers. So this is platform independent. Docker containers are platform independent. Okay. Yeah, so that is why Docker is very popular now. So most of the organizations, most of the companies, they are using Docker currently, right? Yeah, so going forward also, coming 15 to 20 years, Docker Kubernetes is very widely project teams will use. Okay, so DevOps tools, in DevOps tools, Docker Kubernetes is very popular, even Jenkins also, right? So cloud and DevOps coming 15 to 20 years, market would be like this one, coming 15 to 20 years, no doubt about it. Okay, so because every organization they're using cloud infrastructure, right? So every organization they're using automation tools, right? So that is why every organization they're opting Docker Kubernetes for deploying the applications currently. Clear, right, everyone? Anyone having any questions here? Yeah, win and lib same as OS. Yes, OS files, system files. Okay, fine. So anyone newly joined today, can you share your WhatsApp number, email address in the chat? New guys, anyone joined newly? Can you share WhatsApp number, email address in the chat so that I'll provide you recordings here, previous recordings. Can you share in the GoToMeeting chart here? New guys, whoever joined today, can you share WhatsApp number, email address in the chart? Fine. Yeah. Next one is this architecture we'll discuss later. Okay. While working on AWS, we'll see this architecture. Okay. Next one is what is operating system? What is operating system? We are talking about operating system, right? So what is operating system, anyone? What is OS? Real time guys. What is operating system? It is Windows Linux. Yes. But what is operating system? Base OS is a server. Server. Base OS is a server. Okay. Yeah. Operating system is an, it is a interface, right? Operating system is an interface between user and the computer hardware, right? Yeah. So computer hardware always understand binaries. What is binary? What are the binaries? 000, zeros and ones. Binaries are nothing but zeros and ones. 000, 001, 110, 110, like that, right? So computer hardware always understand binary language, but human will not understand that. That is why we require one translator. So that hardware language to human readable language, that should be translated. So who will translate that? Operating system, right? So operating system is an, see here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? So yeah, hardware language to human readable language to hardware will translate vice versa. So which is nothing but operating system, right? Yeah. So here, see here, there is a hardware and an end user. Middle we have operating system. So types of operating systems. What are the types available? What are the types available? See here, single user, single tasking operating system. Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. Only one user can log into the system. He can perform only one task at a time, which is nothing but MS-DOS, Microsoft Data Operating System. So in MS-DOS, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system, right? Second one is single user, multitasking operating system. So in this type of operating system, only one user can log into the system. He can perform multiple tasks at a time, right? So which is nothing but Windows. While browsing internet, we can run background audios. While working on any task, we can run audios, right? So single user can perform multiple tasks at a time in Windows. Okay. Yeah. Next one is multi-user multitasking operating system. What is this? Multiple users can connect to the servers. They can perform multiple tasks at a time. So which is nothing but multi-user multitasking operating system. For example, here Linux and Unix, right? Yeah. So currently in real-time projects, always we are using 90% of the servers we are using Linux only, because Linux is CLI, right? So Windows is GUI. Even Linux also having GUI. What is GUI? What is CLI? Anyone? CLI is command line interface. GUI is graphical user interface, right? So always we are using Linux servers in real-time projects, 90% of the servers. Because of, so we use CLI. CLI is more secure compared with GUI, right? So compared with GUI, CLI is more secure. That is why most of the organizations they are using, so most of the servers they are using Linux servers. Linux servers are very secured, right? Very safe, fine. So these are the things available. So networking part we'll discuss tomorrow. We'll start tomorrow, right? So networking also very important. So whatever terminology we are speaking, that is more important here, right? So everyone should understand that. So day after tomorrow, we are going to start AWS. Tomorrow we are going to work on networks. Day after tomorrow we are going to start AWS. Okay. Yeah. So first, how to create AWS account? How can we connect AWS account? How can we walk through the console? How can we check the services in AWS account? Slowly we'll enter into AWS account. Okay. We don't directly go to servers network in AWS, right? So slowly we'll enter into AWS. So once you are understanding, then we can start working on the AWS console. Clear, right, everyone? Yeah, these basics are very important. So tomorrow we are going to work on networking. So networking concepts are very important here. So different types of networks are available. LAN, yes, here different networks: LAN, PAN, WAN, MAN. Personal area network, local area network, wide area network, and metropolitan area network. So these networks are very important. We'll go deep dive, very deep dive. Okay. Yeah. If you understand these basics, you can easily understand cloud concepts. Fine. The people who are not registered so far, you can register today itself. So still we allow today same link, right? So tomorrow link will be changed. So if you are interested, you can add into WhatsApp group today itself. Okay. So online guys, link will be changed very soon. You can add into WhatsApp group if not added. Okay. So even classroom guys also, you need to add into WhatsApp group as soon as possible. Okay. So tomorrow onwards restrictions will be, yeah. So our people will come and verify. Fine. So that is why, yeah, if you are interested, you can register today itself. How many projects will you cover for only AWS and DevOps? Okay. Yeah. So nearly 15 projects will be covered. Okay. Fine. Any questions, anyone so far? Any theory documents will provide. So once we start working on AWS, we'll provide. Once we start working on AWS, we'll provide you theory documents. Okay. Wait for some time. Wait for some time so that we'll get the documents. Clear, right, everyone? Yeah, tomorrow we are going to work on networks. Okay, so link may be changed tomorrow. You can make the fee if you are interested, and you can add it to WhatsApp group. We'll share the information. We'll share all the information in WhatsApp group only. Clear, right, everyone? Fine. Yeah, we can wind up here. So if you have any more questions, if you want to talk to me, you can reach out to my number. My number already given, 96422111711. This is my mobile number. So you can reach out to me, you can call me, WhatsApp me. So that if you have any questions, we'll discuss. Fine. Yeah, we can wind up here. Thank you all.